Hello everybody. This video lesson I'm going to go ahead and show you how to do solution stoichiometry. So basically the stoichiometry stuff that I showed you already, I'm going to apply it to solutions and show you that really that there's no difference between the problem except for just how you start it. I used the BCA table. What I'm going to do in this problem is I'm going to use this table because I'm going to show you in another video how I would use that for more complex problems. So this problem here, we're looking for how many grams of silver chromate. So I wrote that above the balance equation. That's what I'm looking for. And I'm looking for how much is going to precipitate. Remember, the precipitate is the solid that's going to form. So that's why this is going to be the solid. And it tells me that I have 150 milliliters of 0.5 molar silver nitrate. Remember that I told you in class that when you see this phrase right here, volume of a molar solution, that this is a way to find the moles, because we're going to multiply that volume and we're going to multiply it by moles over volume. So therefore the volumes will cancel. So really whenever you see this phrase volume and a molarity, they're telling you what the moles are. So they're combining silver nitrate and potassium chromate. Okay, so what I did was I put that information here and I put it here. So the first thing I'm going to do is, since I have two reactants and I have the materials for those two reactants, I have to figure out which one will run out first, which one will be my limiting reactant. So first thing to do is get rid of the measurements, get rid of the volume and the molarity, and convert these to moles. Anywhere you see volume and molarity, you're going to convert to moles. So moles of silver nitrate. So I'm going to figure out right here, and to do that I'm just going to take that 0.150 liters. I'm making the conversion from milliliters to liters here. I'm going to multiply that by the molarity, which is 0.500 moles per liter. And what I can do is do that calculation. I'm going to end up with 0.075 moles of silver nitrate. Okay, so that's my starting number of moles, 0.0750 moles. Do the same thing for my potassium chromate, moles of potassium chromate, K2CrO4. I'm going to start with the 0.100 liters, multiply it by 0.4 moles per liter. Okay. So to do this calculation, I have 0.0400 moles of potassium chromate. Oops. Okay, so put that here, 0.0400 moles. Okay, this is 0, this is 0. My change is minus 2x minus x, based on the coefficients, don't forget, based on the change in the reaction, plus x here, and plus 2x right here. Okay, so I'm going to figure out my limiting reactant. So limiting reactant is going to go down here. So we got to figure out which one runs out first. Well, if I look at the moles of silver nitrate versus the moles of potassium chromate, you can clearly see that I have less of the potassium chromate. But don't forget that I use more of the silver nitrate in the solution. So you can't just say that the smaller one runs out, because you have to look at both B and C to figure out limiting reactant, how much we have and how much gets used in the reaction. So if I look at this, obviously there's a 2 change here, right? This is going to change twice as fast as the potassium chromate. So it looks like I don't have enough of the silver nitrate, and it looks like that's probably going to run out because it looks like I need about twice as much. So my hunch is silver nitrate is going to run out. So I'm going to start with the silver nitrate, 0.0750 moles, and I always convert to what I think is the excess reactant. Okay, so I'm going to convert to the moles of potassium chromate. Okay, so I start with silver nitrate, just a 2-to-1 ratio, moles of silver nitrate on the bottom, moles of potassium chromate on the top, and it would be a 1-to-2 ratio. So just divide that in half and I should end up with 0.0375 moles of my potassium chromate. Now remember, what this means is this is how much potassium chromate that I need to have. Okay, I need at minimum, I need this amount to react with 0.075 moles of silver nitrate. Well, if I compare that up here to what I actually have, I clearly have way more than I need. So, by default, this has to be my limiting reactant. And there you go. There's your limiting reactant. Now, notice what happened here. Once I converted these to moles, right? This is the same thing we did in the previous stoichiometry. Nothing new. So don't let this throw you off. Just get everything back to the moles and follow the same pattern each and every time. So now I know what my limiting reactant is. I'm going to use that to find my mass of silver chromate, the solid. Okay, so to do that, I take my 0.075 moles of potassium chromate, or sorry, silver nitrate, because that's my limiting reactant. And I'm going to convert that from silver nitrate to the moles of silver chromate. It would be a 2-to-1 ratio again, so it's going to follow the same pattern we saw here. A 2 on the bottom and a 1 on the top. And it's going to finish off with the mass conversion using molar mass. Silver chromate. Grams of silver chromate here. And that number is 331.74 for every 1 mole. So notice my units cancel nicely. And if I do that calculation, 0.075, divide that by 2, multiply it by 331.74, we end up with 12.4, 3 significant figures, so 12.4 grams of silver chromate left over. Okay, so again, like I said, nothing new there, pretty much the same thing as we did before. Okay, we took the molar concentrations in the volume, converted it to the moles, and pretty much plugged into the table and solved it. Now, for this particular problem, I don't really need the table, but I want to kind of build off this problem in another video and show you what to do and how this table can be pretty useful for understanding the actual chemistry that's going on. So hopefully that helps you get a little better idea of how to deal with solution stoichiometry and how to convert volumes and molarities into moles. Thanks.